In geometry, we define new terms using terms that were previously defined. For example, we say a rhombus is a special kind of parallelogram where all the sides are equal. A parallelogram, in turn, is a special kind of quadrilateral where opposite sides are parallel in pairs. A quadrilateral is a figure that is constructed using line segments. A line segment is a portion of a straight line that has two endings. But we cannot define a line, so it's an undefined term. In geometry, we have undefined terms of point, line, and plane. We cannot define those terms, and we just use them, we assume them as primitives. All defined terms are defined using undefined terms or previously defined terms. A defined term is logically equivalent to its description or definition. Axiom. Axiom is a true statement that we cannot prove. And we have certain axioms in geometry. A theorem is a true statement that we are able to prove. Sometimes we use term postulate. Postulate means either axiom or theorem. At that specific moment in the context, it doesn't really matter if we are able or not able to prove it. So we say postulate. The same is in colloquial language. You often use the word law or rule. They're similar to the word postulate. Corollary is a special kind of a theorem that follows a main theorem. Lemma is a special kind of theorem that precedes main theorem. It's an auxiliary theorem that will be used to prove the main theorem. A conjecture is a possibly true statement that is not proved yet. So it's like a theorem, but we don't know the proof, and it's possibly true. Property is like a distinguishing characteristic. It's similar to a concept from object-oriented programming. Necessary and sufficient conditions. Those are special conditions that, when combined together, can be used to determine a specific term. Let's see several examples about parallelograms. So the first statement is our definition. A parallelogram is a quadrilateral, like a special kind of quadrilateral where opposite sides are parallel in pairs. These three are properties, and as we can see, they work only in one way. Like converse does not work here. Parallelogram has opposite sides equal, but it doesn't mean that a figure that has opposite sides equal will be parallelogram. For example, a hexagon has opposite sides equal, but it's not a parallelogram. Parallelogram has opposite angles equal. Parallelogram has diagonals bisect each other. So all these three are properties, and the converses for them don't work. All these five are necessary and sufficient conditions. So they are logically equivalent to our term parallelogram. If a quadrilateral has opposite sides equal in pairs, then a quadrilateral is a parallelogram, and converse works. If a quadrilateral has two opposite sides in one pair, both parallel and equal, then that quadrilateral is a parallelogram, and converse is also works. Here we have conjunction or intersection. If a quadrilateral has diagonals bisect each other, then this quadrilateral is a parallelogram. If quadrilateral has adjacent angles supplementary, then that quadrilateral is a parallelogram. If a quadrilateral has opposite sides equal in pairs, then that quadrilateral is a parallelogram. We can see that opposite sides equal, opposite angles equal, diagonals bisect each other, they are present here. However, in here, everywhere we have another additional condition that a figure must be a quadrilateral. So it is like a necessary and sufficient condition.